Hello, in this lesson, I want us to talk about the distance between 2 points. But before we explore the concept, can we revisit the concept of the Pythagoras theorem? So, if I have a triangle like this, we say like this, and then I call this line A, this line B, and this line C. Line C squared is the same as line A squared plus line B squared. But if I want to get C, I can take square root on both sides. So if I take square root of C squared is equals to the square root of A squared plus B squared, then the answer becomes C is equals to the square root of A squared plus B squared, because the square root of C squared will be C. Then here, because I have addition, there is no need of reducing or taking the square root, let it remain like that. So keep this knowledge in the back of your mind when you sit to explore this concept. So if I have 2 points like this, let's say point A is 1, 2, and point B is 4, 6, and I try to plot them the Cartesian plane. In my case, can just plot them in this graph. Let me show you. That's how I plotted the points in this graph, and as you can see, this point 1, 2, and then this is point 4, 6. If I show the distance, this is the distance we are actually talking about. You see that red text hovering around the distance. So this is the distance we are talking about. And to get this distance, we need to take the distance of this line squared plus the distance of this line squared, and then get the square root of that summation, which of course is the logic of the Pythagoras theorem. So let's come back here. And based on our Pythagoras theorem logic, I can say A is equals to this x2 minus x1. Then I say B is this y2 minus y1. But you see, we already have all these values. So this is x1, this is y1, this is x2, and this is y2. So here, if I have all those values and I want to get this distance here, I can just simply say, replace the values here first, then take A is equals to x2, which is 4, minus x1, which is 1, and then which now becomes 3, and then B is the same as y2 is 6 minus y1, which is 2, now becomes 4. So I read off A and 4, and I know to get this distance based on the Pythagoras theorem, I need to take the square root of this line squared, which we have given it as A squared, then plus B squared, which is this line, then I take the square root. So let me call this line C. So this line C, I can say is equals to A squared, but we already have A, which is 3. So I can take it as 3 squared plus B, which is 4, but now squared. So C would be equal to square root of 3 squared is 9 plus 4 squared is 16. So C will be equal to 9 plus 16, which is 25. So the square root of 25, which is 5. So the distance between these 2 points is 5 units. Can we try another example here? Here I have 2 points, which are 2, 3, and 8, 7. So let me say point A is 2, 3, and point B is 8, 7. So I can call this x1, this y1, this x2, this y2. So to get the distance between these two points, I only need to apply the logic of Pythagoras theorem, where I can say, first of all, I can say A is equals to x2 minus x1, which is equals to x2 is 8 minus x1 is 2. So the answer becomes 6. So it's 6. Then B is y2 minus y1, which is equals to, what is y2? Y2 is 7 minus y1, which is 3. So the answer becomes 4. And then I say, from our logic of Pythagoras theorem, I say C is equals to the square root of a squared plus b squared. So here I get the square root of a squared, which is 6 squared plus 4 squared. So I get square root of 36 plus 16, which is the same as the square root of 52. 36 plus 16 is 52. So what is the square root of 52? You can use our calculator and see what is the square root of 52. And you see where we have square root, which that becomes, then distance between those 2 points is 7.211. Can we try another example where we have the question 2, find the distance between the points 1, 4. So I can call it here 1, 4, and then B 5, 9. And then we can say this is x1, this is y1, this is x2, this is y2, and then I get A, which is the same as x2 minus x1, which is the same as x2 is 5 minus x1, which is 1, so I get 4, and then B is equals to y2 minus y1, which is the same as I already have y2 as 9 minus y1, which is 4, so it's the same as 5. And then to get C, which of course is the distance in our case, we apply the Pythagoras theorem. I say it's the same as a squared plus b squared, which is the same as the square root of a squared is 4 squared plus 5 squared, which is the same as the square root of 16 plus 25, which is the same as square root of 41. We see 41. So what is the square root of 41? Just go to our calculator. The square root of 41, we write it, yep, 41, then square root, which is 6.40, is 6.40, and that's our distance between these 2 points. Can we try the last example? It says a line joins points A, which is 3, 2, and B, 9, 6. Find the length. So in short, it's asking us to find the distance between the 2 points, and the first point A is 3, 2, and point B is 9, 6. So as usual, we have A, which is given by x2 minus x1, but we already have all those values here. This is x1, y1, x2, y2. So here we have x2, which is 9, minus x1, which is 3. So then minus 3 is 6. And then we can also have B, which is given by y2 minus y1, which becomes y2 is 6 minus y1, which is 2. So 6 minus 2 is 4. So C, which now becomes our distance, can be given by a squared, a squared plus b squared, which becomes we already have here the square root of 6 squared plus b squared, which is 4, but now squared. So it becomes 6 squared is 36 plus 4 squared is 16. So it becomes the square root of 36 plus 16, which is the same as, let me show you, that 6 plus 16 is 52. It's 52. Then the square root of 52 is the same as, let me show you here, the same as 7.211. I think I repeated that example with the one which was in the graph, if I'm not wrong, or something similar, or just different coordinates. But that's the logic of the distance between 2 points. If you don't want to use A and B or C, now you can apply this formula, but generally x2 minus x1, you can just give it A, and then y2 minus y1, you can just give it B. Then you use the normal Pythagoras theorem logic to solve the distance between two points. So bye for now. Let's meet in the next lesson.